Okay, so a couple problems from grading your homework the other day as a group. Look at a couple of these. Number 12, you're given the function f of t equals root t. Clearly my domain has to be t is greater than or equal to 0, positive numbers under the root. Square root of t, there's an implied positive out in front, so f of t is greater than or equal to 0. Note my notation. Domain, input, independent variables t is greater than or equal to 0. Output is your range. F of t is the output, and f of t is greater than or equal to 0. Zeros are when the function equals 0. When does this function have an output of 0? It has an output when t is 0. Okay, ditto for 12b. I'm given a function g of t is the square root of 9 minus t. What's my domain? I can only put in t values that give me a positive output here. What values would those be? T is less than or equal to 9. Anything over 9, 9 minus that number would be a negative number. Anything under 9, including negative numbers. Note that 9 minus 7 would be 16. So my domain is t is less than or equal to 9. Again, an implied positive in front of the squared root. So my output is g sub t is greater than or equal to 0. When does this function equal 0? When is my output 0? When the square root of 9 minus t is 0, and that occurs when t is 9. 12c was similar to what was on your last test. I have the square root of 9 minus t squared. What values can I put in for t so that 9 minus t squared is positive? And clearly those are going to be numbers in between negative 3 and 3. You can do a signpost analysis if you want with 9 minus t squared, because 9 minus t squared will factor into 3 minus t times 3 plus t. And you can then go ahead and set up your signposts at negative 3 and at positive 3. To the left of negative 3, positive times negative is negative. In between negative 3 and 3, 3 times 3 is 9, which is positive. And to the right is negative. Or again, you can simply eyeball this and say, hey, what numbers can I subtract from 9 to still keep this thing positive? Well, t squared's got to be between 0 and 9. What numbers will do that? Negative 3 to 3. What's my output going to be? What's my range? Well, clearly if t is 0, I can get as high as 3, because root 9 is 3. And then how small can this value get? Well, again, it's implied positive square root, so your square root of positive square root, the smallest this thing could be is 0. So g of t is going to be in between 0 and 3 as an output. For number 20, you were kind of okay on getting the domain, or what the function gave you. It was the sum of the interior angle measures in a polygon. That was n minus 2 times 180. We might remember that from geometry class. Sum of the angles in a triangle is 180 degrees. In a quadrilateral is 360 degrees. So 4 quadrilaterals, 4 sides, 4 minus 2. 2 times 180 is 360. Pentagon has 3 times 180 or 540 degrees as the sum of its interior angles. And the part that we followed up a little bit on was domain and range. My domain, if I'm referring to polygons, domain has to be integers greater than or equal to 3, because the minimum number of sides of a polygon is 3. Polygons don't have 3.1 sides, so I'm counting from 3 up, so that's the integers greater than or equal to 3. My outputs are not all real positive numbers. My outputs are simply multiples of 180. I get outputs of 180, 360, 540, 720, etc. So for 22a, we're looking at the ceiling function. The ceiling function is the round up function. If I'm over a certain integer, I round up to the next nearest integer, to the next the next least integer above where I am. The next greatest integer above where I am. So if I'm at negative 0.7, for example, I'll round up to 0. If I'm at 1.1, I round up to 2. But if I'm at an integer, the ceiling function states that I stay where I'm at. So my graph then is going to take numbers here from 0 to 1, round them up to 1. At 0, I stay at 0. And at 1, I stay at 1. Numbers from 1 to 2, round up to 2. At 1, I've got an open circle here because 1 is 1. And then I round up and I've got a closed circle at 2. Same thing over here. 0 is 0. And then numbers in between negative 1 and 0 are going to round up to 0. So there's 3 steps of this ceiling function. So what I found useful here for 22B was to get your graph done first. You know, see if you can plot out for certain times, what's your cost going to be. Well, clearly my cost over the first hour is going to be $3. I don't pay anything if I don't park at all, and I pay, it says up to including the first hour, closed circle at 1 at 3. And then what happens? I go up for the whole next hour, I go up another $2 to get to 5. So my rule winds up being 3 plus, and then I've got the first hour is taken care of, so if I'm at 1.2 hours, let's say, 1.2 minus 1 would be 0.2, round that up to 1, so I'm adding on $2 for that next partial hour past 1. So I get a rule basically thinking about what we just did with translating and stretching. I'm translating the original ceiling function, it's up 3, and it's going to be a vertical stretch by a factor of 2, and I'm going to have a horizontal translation. But again, didn't need to know all of that to kind of get this done. And you could try out, different rules and see what you come up with. But that'll do it. That'll graph this.